hills above Sevastopol, and the air itself seems to vibrate before the sound arrives. Somewhere behind German lines, hidden within a purpose-built spur of railway track threading through the Crimean countryside, a machine larger than anything ever built for war draws breath. Its barrel, over 30 meters long, rises at a shallow angle towards a distant Soviet ammunition depot dug deep into rock. Engineers in gray overalls check gauges along a carriage line stretching the length of several football pitches. Then, with a concussion that flattens grass for hundreds of meters and sends a column of displaced air rolling across the valley, it fires. Seconds later, 7 kilometers away, a fortress believed impervious to conventional artillery erupts from within, its ceiling collapsing onto a magazine sunk 30 meters beneath the earth. This is Schwerer Gustav, the heaviest railway gun ever built, and the shell that has just traveled across the Crimean sky weighs more than a small car. Soviet defenders inside Fort Maxim Gorky have never faced anything like it, nor, in truth, has anyone. Yet for all its power, for all the resources, steel, and manpower poured into its creation, this extraordinary weapon will fire only a handful of times in actual combat before vanishing from the war almost as suddenly as it appeared. The question this story must answer is not how such a machine was built, but why something so immense achieved so little, and why Nazi Germany believed it needed a gun of this scale at all. By the late 1930s, German military planners faced a specific and stubborn problem. France's Maginot Line, a chain of deep, heavily reinforced concrete fortifications along the German border, was designed to withstand any artillery then in existence. Adolf Hitler, reportedly briefed on the line's construction, asked Krupp, Germany's principal arms manufacturer, whether a gun could be built capable of destroying such fortifications from a safe distance. Conventional siege artillery of the era, however powerful, could not reliably penetrate several meters of reinforced concrete buried beneath earthworks. Existing German guns, including the substantial 42-centimeter Big Bertha howitzers used in the First World War, lacked the range, shell weight, and penetrating force required. Krupp's engineers, led by chief designer Erich Müller, concluded that only a radically larger weapon, with a caliber far exceeding anything previously constructed, could achieve the necessary destructive power. Design work began around 1936, envisioning a gun so large it could not be towed or self-propelled, but would instead require its own dedicated railway. This presented immediate strategic complications. A weapon dependent on rail lines could only be positioned where suitable track existed or could be built, and its sheer size made concealment from aerial reconnaissance extremely difficult. Nevertheless, the perceived threat of the Maginot Line's fortifications and Hitler's evident enthusiasm for monumental engineering kept the project moving forward, even as France itself was defeated in 1940 before the gun was ever finished, rendering its original purpose obsolete before it fired a single shell. Construction of what became known as Schwerer Gustav, meaning Heavy Gustav after Krupp's chairman Gustav Krupp von Bohlen und Halbach, proceeded through the following years despite Germany's shifting strategic priorities. The finished weapon possessed an 80-centimeter caliber barrel, a figure almost without precedent in artillery history, capable of firing shells weighing between 4 and 7 tons, depending on the type, either high-explosive or armor-piercing concrete-busting rounds. The complete assembly, including its twin parallel rail carriages, measured approximately 47 meters in length and weighed around 1,350 tons. Moving it required a dedicated crew historian's estimate at over 500 personnel, encompassing artillerymen, railway engineers, anti-aircraft defense units, and construction battalions tasked with preparing curved double-track spurs strong enough to bear its weight. Assembly at a firing position alone could take several weeks. The barrel itself required periodic replacement, since the extreme pressures of each firing eroded the rifling, and Krupp manufactured a limited number of spare barrels to extend the weapon's operational life. Testing began at the Rugenwald Proving Ground in 1941, where engineers worked through significant technical challenges, including recoil forces that threatened to damage the rail carriages themselves, and the sheer logistical difficulty of transporting shells so heavy that specialized cranes were required simply to load them into the breach. Reports from Krupp's engineering team indicate persistent concerns about accuracy at extreme range, given the shell's long flight time and vulnerability to atmospheric conditions. A second, near-identical gun, unofficially referred to as Dora, was also constructed, named after the wife of the project's chief engineer according to some accounts, though the naming's exact origin remains debated among historians. By early 1942, with the original Maginot Line target long irrelevant, German High Command sought a new application for this extraordinary weapon and found one in the ongoing siege of the Crimean port city of Sevastopol, where Soviet coastal fortifications, including the underground Fort Maxim Gorky complex, had resisted repeated German assault. Transporting Gustav to the Crimea required its own engineering effort, with railway units constructing a spur line specifically to bring the gun within range of the Soviet defenses, a logistical undertaking that itself consumed considerable time and resources before the weapon could contribute to the battle at all. If you're enjoying this journey through history, subscribing genuinely helps us continue bringing remarkable, true stories like this to the channel. Once positioned near Bakhchisarai in early June 1942, Gustav began firing on Sevastopol's fortifications as part of the German 11th Army's broader siege operations under Field Marshal Erich von Manstein. Records indicate the gun fired approximately 48 rounds during the entire Crimean campaign, targeting Fort Maxim Gorky, coastal batteries, and reportedly an ammunition depot in the vicinity of Severnaya Bay. Contemporary German reports describe the destruction of a heavily fortified magazine buried deep beneath rock, an achievement conventional artillery of the period could not have accomplished. However, available evidence does not suggest Gustav's contribution was decisive to the fall of Sevastopol, which resulted primarily from a combination of sustained infantry assault, conventional artillery bombardment, and aerial attack over many weeks. The gun's practical limitations became evident during deployment. Each firing required extensive preparation, its rate of fire measured in shells per hour rather than per minute, and its enormous, fixed-rail position made it vulnerable to counter-battery fire and air attack had Soviet forces possessed sufficient reconnaissance to locate it precisely. Historians continue to debate how meaningfully its psychological or symbolic impact affected Soviet defenders compared to its measurable physical destruction. No other nation built anything directly comparable to Schwerer Gustav, since no other combatant pursued railway artillery at this exact caliber and scale. The closest parallels were German railway guns of considerably smaller bore, such as the 28-centimeter Krupp K5, which saw far more extensive combat use precisely because its size allowed greater mobility and flexibility. The United States and Soviet Union both developed heavy siege artillery during the same period, but neither pursued a weapon approaching Gustav's dimensions, judging the resource investment disproportionate to likely battlefield value. This divergence reflects differing strategic assumptions rather than differing engineering capability. Where Germany, particularly under Hitler's personal interest in monumental weaponry, invested heavily in singular, spectacular systems, other powers generally prioritized mass production of moderately sized artillery that could be deployed flexibly across multiple fronts. Evidence suggests German commanders themselves, including some artillery officers, privately questioned whether Gustav's enormous logistical burden was justified by its limited rate of fire and narrow range of suitable targets. Assessing Schwerer Gustav's wider historical significance requires separating its undeniable engineering achievement from its actual military contribution. It did not alter the outcome of any campaign, nor did it meaningfully influence subsequent artillery doctrine, since no major power pursued comparable weapons after the war. Its immense size ultimately worked against sustained usefulness, consuming resources, rail capacity, and specialist manpower that arguably could have supported more versatile weapon systems. Following Sevastopol, Gustav saw limited further use, reportedly positioned near Leningrad and later Warsaw during the 1944 uprising, though evidence for its firing in these locations remains less thoroughly documented than the Crimean campaign. As Allied forces advanced in 1945, German crews destroyed the gun to prevent capture, and no complete example survives today, though photographs, technical drawings, and Krupp's own engineering records preserved in post-war archives allow historians to reconstruct its specifications with reasonable confidence. Some components and fragments have reportedly surfaced in subsequent decades, though their attribution remains debated. Its legacy endures principally as an illustration of engineering ambition outpacing practical military value, a case study frequently referenced in discussions of resource allocation during total war. Return, then, to that June morning above Sevastopol, to the column of displaced air rolling across the valley and the fortress erupting from within. What that moment represented was not the unstoppable weapon German propaganda sometimes implied, nor merely an engineering curiosity, but something more complicated, the outer edge of what industrial-age warfare could physically achieve, built for an enemy fortification system that had already ceased to matter by the time the gun was finished. The engineers and crews who built and operated Gustav could not have known, standing beside their steel colossus in 1942, that history would remember their creation less for what it destroyed than for what it revealed about the limits of scale itself. 48 shells, fired from perhaps the most ambitious artillery piece ever constructed, could not compensate for a rate of fire measured in hours, nor for a weapon so vast it could scarcely be hidden, moved, or protected. And yet dismissing Gustav as mere folly overlooks the genuine, if narrow, destructive capability it demonstrated, capability no other gun on Earth then possessed. Its story endures not as a tale of victory or even meaningful battlefield contribution, but as a monument to the point where engineering ambition, unchecked by practical constraint, produces something extraordinary and, in the same breath, almost entirely without purpose.